So, electron configuration. There we go. Okay. So we're also going to talk about orbital diagrams today too. So these two things are what we're going to discuss. Electrons arrange their orbitals so that they have the lowest energy levels filled. Okay. The only time they leave those energy levels, which are called their ground states, is when they get excited. We found a couple different ways to excite them the other day. We used electricity. We also used flame, heat, to get them excited. Okay. We are going to be using these electron configurations in a way that we can end up describing the location of that last electron. And these are the codes, essentially, that we do that with. Okay? So this is the electron configuration for arsenic. And it's going to tell us where that electron lands. Okay? We also have these orbitals. Okay? And the orbitals then we can use to show the electron, like how many orbitals each one of these areas has. Okay? And that's what those electron orbitals look like. And I'm going to show you how to do this as we move through. Okay? So when we fill these, we end up having an up arrow and a down arrow. And the orbitals, if we have an s orbital, it's going to get one box and it has 2 arrows. P orbital number of boxes would be 3 and it has 6 arrows possible. D is 5 and it has 10 arrows possible, and F is 7 and it has 14 arrows possible. All right. So rules for creating an electron configuration: they have to fill the lowest energy orbitals first. The electrons are placed into equivalent orbitals individually before they're paired up. Just like your bunk beds yesterday, you couldn't have somebody in the top bunk until the bottom bunk was filled. Do you remember that? And then no 2 electrons can have the same quantum number, which we learned about quantum numbers the other day. Okay? We know our different rules for S, P, D, and F. And then we're going to write the electron configuration for aluminum. Okay, so I'm going to show you how to do that. So first of all, you're going to find aluminum on your periodic table. So aluminum is number 13. It is on your periodic table. If you look, you have hydrogen here. You have helium right next to it, if you think about it right next to, or else it's way over here, however you want to think about it. Okay. Then you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then helium would have been above that. And then over here you have sodium, magnesium, and then finally aluminum. Okay, so that's how your periodic table is set up. You guys good with that? All right. So do you ever remember playing a game called Chutes and Ladders?
Yes.
Okay, so Chutes and Ladders, you have these numbers and you start at 1 and you keep going until you get to 100, and whoever gets to 100 first wins. And along the way, you have these ladders that can take you up higher numbers. I'm going to show you how to do the ladders in a few minutes, but right now we're going to play Chutes and Ladders without any of the chutes or ladders. We're just going to go 1 through 100, or 1 through 13 in the case of this. Okay. When you do these electron configurations, you're always going to start at hydrogen. Okay. That's where you're going to start. So hydrogen and helium on your quantum numbers periodic table are right here. So I'm just going to move helium over here for now. Everybody cool with that? Okay. So hydrogen and helium, going back to your quantum numbers periodic table that you did the other day. Okay, because remember I said at the beginning that you need periodic tables. So you need a quantum numbers periodic table in front of you as well. I don't have that. Did you made one though? You just don't have it with you?
I would, yeah.
Here's money for today. You need to get one for me and it's done. All right, so we're going to start at hydrogen and helium. What is the N value of hydrogen and helium? On your quantum numbers periodic table, go to the very top. What is the N value for hydrogen and helium? 1. What block am I in? SPDF, what block am I in? S. And I need both electrons to get to aluminum, yes?
Yeah. I am lost. What are we doing? I mean, I can see what we're doing right now, but how did you get there?
So
I see. Okay, I got it.
you're at aluminum. We're going to aluminum, right?
Yes.
We're going to start at hydrogen and helium because we always start back at number 1. Okay? We always start at 1. Always start at 1. You good with that? Hydrogen and helium, this is 1 and 2. So what is my N value off of your quantum numbers periodic table? What is the N value for hydrogen and helium?
1.
So that's where I got that. What block are hydrogen and helium in? You have it color-coded. S. That's where I got that. And to get to aluminum, I need both of these electrons, yes? There's my 2. That's where this 2 came from. All right. What comes after numerically hydrogen and helium?
Lithium, beryllium.
All right, lithium and beryllium. So these 2 come next. What is my N value for lithium and beryllium? 2. What block am I in? And I need both of those electrons to get to aluminum, yes?
Yes.
All right. What comes after beryllium numerically?
Boron.
Boron. So I'm coming over here. What is the N value for boron?
2.
2. What block am I in
P.
for these? P. And do I need all of these to get to aluminum? How many is that?
6.
6. What comes after neon?
Sodium.
Sodium. So I need sodium and magnesium. What is my N value for sodium and magnesium? 3. What block am I in? Do I need both of those to get to aluminum? What comes after magnesium? Aluminum. Okay. What is my N value for aluminum? 3. What block am I in?
P.
P. And I just need how many electrons?
1.
Just 1. That is the electron configuration for aluminum. Good? All right. Vanadium. I'm going to go up to a different periodic table to do vanadium because it's going to make it easier. So I am right here. I'm going there. I'm going to start back at number 1. Okay? So I start back at 1 here. I am going to vanadium. I need both of these. What is my N value for both of those? Okay? And what block am I in? This is the S block. And I need how many electrons? 2. After this guy, number 2, I go down and I get these 2. Because numerically, after 2 comes 3 and 4. Told you didn't need a calculator.
True.
Okay. What is my N value for lithium and beryllium? 2. What block am I in? And how many electrons? 2. Okay. Then numerically, I go over here. Are you understanding this? Or have you shut down on me, Ray? Have you shut down on me, or are you understanding this? Okay, that's fine. Well, I mean, it's not fine, but I just wanted to make sure that you weren't shutting down on me. All right, so I go over here to number 5. I need all of these. What is my N value for all of those?
2p.
Yep, 2p, and I need all 6 of them. Then numerically, I come down here, because after number 10 is 11. 3s2. Then numerically, after 12, I come over here and I need all of these. 3p6, good. Then numerically, after 18 is 19 and 20. So 4s2. Now, after those, I come over here. What? 3D. Yes, because remember, your N value when you get to the D block is your period minus 1. So this is going to be 3D, and I only need 3 of them. Make sense? Good.
Would that block come earlier, or you
Nope.
based on, oh,
Yep. This is the
Roll over.
you go numerically. Okay? So this is 20, this is 21. So follow the numbers. The numbers will, as long as you stay in order of the numbers, you'll get your configuration right.
okay, but you're like following the shape and then you do the subtraction additionally, but you keep the order.
Yeah. Good? Everybody good?
Yeah.
All right. So I did that one on the previous slide. All right, this is just showing you the number at the front is your N value. The P then is going to be what block you're in, and then the number at the top is going to tell you the number of electrons that are in that orbital. Now, if you're given one of these and told to identify, so you don't know what this is, okay, one way that you can figure out what it is you can add up these superscripts. So add 2 plus 6 plus 6 is 10, 12, 18, 20, 33. Arsenic should be 33. And it is. Yep, arsenic is number 33. So if you add up these superscripts, that's the atomic number for the element that you're trying to identify. Okay. It's also a good way to double check your work. Did you get all the electrons placed? If you didn't, it's a good way to kind of catch that too. Okay. All right, orbital diagrams then. Orbital diagrams are essentially your M value on your quantum numbers. Okay, you're placing those. So that's why S gets 1, because your M, your options on your quantum numbers periodic table. So if we go back to this guy here, okay, you have 1 option for M. You're going to get 1 blank for M for when you do orbital diagrams, when you're in the S block. When you're in the P block, you're going to get 3 lines because these double up. So you're only going to get 3 lines for that. How many lines do you get in the D block?
5.
5 corresponds to these values because here, this is the same orbital. So if you are this guy, he's in the same orbital with this one. This is where the bunk beds double up. Okay? So here, your pink room, this is your P orbital, right? Your pink room had 3 bunk beds. And then here, you doubled those bunk beds up with these 3. Okay? Your sunny room only had 1 bunk bed yesterday, right? Okay? So you had one bunk bed there, and they doubled up when you got the second element in. Your F orbital is going to have how many bunk beds or how many lines for your orbital diagram?
Which one?
F. Seven. Yep. So here are your 7 bunk beds. And then you can double up the bunk beds once you run out of lines. Okay? So this is how those bunk beds look for carbon, for example. And you don't have to write these X, Y, and Z down here. We don't need that. Okay, that's just extra. So if you were doing carbon, this is the electron configuration for carbon. You would have your hydrogen, helium, lithium, beryllium, boron, carbon. You can't double up these arrows until you have all 3 of these filled. So you have to have somebody in the bottom bunks before you can double up. Okay. Here is nitrogen then. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Down here's oxygen, and this is where we can finally double up. Okay. When we're looking at, we talked about ions, remember? Remember us talking about ions? Okay. When you are dealing with ions, the cations will form. They're going to lose electrons from their outermost s orbital. So this is the electron configuration for iron. Okay. Iron forms a +2 charge. What is the outermost? What is the highest N number for iron in this electron configuration? What's the biggest N value here? 4. This is where those 2 electrons are going to get lost. So it pulls it out of the s orbitals, the higher N values first. Yeah.
So the electrons would be exponents.
Mm-hmm. Yep.
So it just pull the entire 4 thing out.
Yep. So this is what it ends up looking like for the electron configuration.
But if it were to, like, say, pull 1 out, then we would just be left with 4s1.
Yeah, it doesn't happen though. It's going to lose both of them. However, if you have something like, let's just do sodium, okay? Sodium's 1s2, 2s2, 2p6, 3s1. Here it would just pull 1 because it only has 1 to go.
Yeah, because it can only have 1 on the last one because the bunks have to be filled before it.
Yeah, so sodium would have 1 bed in the 3rd level that has 1 electron in it, and that's going to get pulled out. And it's going to get given to something else like maybe fluorine. So fluorine has this electron configuration. Okay. All the elements on the periodic table are striving to have, and I'm personifying here, they don't actually have emotion or needs or wants, okay? But they want to have that outer energy level filled. For fluorine, if it gets 1 more extra electron, it's full. So if fluorine gets 1 extra electron, its energy level is filled, right? If sodium gets rid of 1 electron, it has its energy level filled. So sodium gives that electron to fluorine, and now they have the same electron configuration is neon, and that makes them satisfied and happy, stable. Makes the atoms or the ions are stable then. And that's like your table salt, for example. That's why your table salt's stable. It's not going to react with stuff really. So table salt, this is not, table salt is has oh, I did that the wrong one. Yeah, so if you think of this one as the sodium, so it was 3S1, this was 3P5, so this is chlorine, this is sodium, okay? If this sodium gives up one of its electrons to here, then they'll both be stable. Make sense? And that's ultimately what they're trying to do. All right. So write the electron configuration for chlorine, and then we want to do the orbital diagram for that. So I'm going to go back to this periodic table. I'm going to wipe it clean here, or try to. And we are going to go to chlorine for this, and then I'm going to do the orbital diagram for you as well. Okay? So we are going to write the electron configuration for chlorine. Chlorine is found right here. Where do I start my electron configurations?
By hydrogen.
By hydrogen. So what is my N value for hydrogen and helium?
1.
1. What block am I in?
S.
How many electrons do I need?
2.
2. I go from hydrogen and helium down to lithium, beryllium. What is my N value for lithium?
2.
What block am I in?
S.
And how many electrons do I need?
2.
2. Then from beryllium, I go over to boron, right? Number 5. What is my N value for this section here? 2. What block am I in? P. And how many electrons do I need? 6. Then after that, I go down to sodium. What is my N value? What block am I in? And how many electrons do I need? All right, I come over here. What is my N value? 3. What block am I in? P. And how many electrons do I need? 5. 1, 2, 3, 4, 5. That is the electron configuration for chlorine. All right, let's do the orbital diagram for chlorine. So the orbital diagram, S's get how many blanks?
1.
1. That corresponds to the single M value for that. So I'm going to go 1S, 2S. Then I need to go to P. How many blanks does P get?
2. Not 3.
3. This is the -1, 0, 1 for my M value. Then I'm going to go 3S. And then 3P, and again, it gets 3 blanks. You have to put all 3 here. Even if it's like aluminum and it's only using 1, you still have to have 3 orbitals drawn there. Okay? All right. So I'm going to go back and I'm going to do my arrows. My arrows will correspond to the superscript here, the exponent. So if this has 2, I need to have 2 arrows in that block. So 1, 2. For this one, 1, 2. Now watch what I do on the P. Okay? You go up, 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 and then you double up. You got to put everybody in the lower bunks before you can double up. Down, down, down. 3S, I have 1, 2. 3P, I'm going to go up, 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 then down, down, and I don't put one in this orbital because there isn't one there. That one's free.
I'm lost. Why did you not put no orbital?
Because I have only 5 to place. So I placed 1, 2, 3, 4, 5.
I see.
Good? All right. Let's see. I have a we do, I believe. Okay, so titanium. So you are going to work with the person next to you to do the orbital diagram, and the electron configuration of titanium is right here. Let's see if you can get that done, and then I'll put the answers up here in a minute or two. Start back at the beginning. Always start back at hydrogen. All right. Need more time?
Yes.
Okay. Good. I'm going to set my marker down. All right, so for this one, I'm going to start back at hydrogen and helium. 1s2. I'm going lithium, beryllium. 2s2. And then I come over. I do boron through neon. 2p6. Then I pick up my sodium and magnesium, which is 3s2. Come over here, aluminum to argon is 3p6. Potassium and calcium are 4s2. And then I'm going to come over here. This is what for my N value? 3. Because it is period. Because it is period minus 1. Good? So 3d, but I only need 2 electrons to get there, so 3d2. Okay? Orbital diagram then. I'm going to have 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. How many lines do I need to draw? 5. This is the -2, -1, 0, 1, 2 off of your quantum numbers periodic table. Okay? So now I go back and I do my electrons. I've got 2 here, 1, 2. I've got 2 here, 1, 2. I have 6 here. I'm going to go 1, 2, 3, 4, 5, 6. 3s, 1, 2, 1, 2, 3, 4, 5, 6. 4s, and then 3d. Remember, you can't double up those electrons. They have to be.
They're not supposed to be 3 lines between P and 3s.
Yeah, this is the 3p. So this is the -1, 0, 1 for the orbitals. What do you mean 3 lines? Is there supposed to be, or is it? I don't know what you said. Can you say that again? What was your question, hon?
Isn't there supposed to be 3 lines between P and 3s?
There's 3 lines in here, you mean? Right here? I don't know what you mean.
No, I'm confused.
So this is my 1s. That gets 1 blank. Remember, this is the M value for these is 0. Right? Off your quantum numbers periodic table. Your M as in Mary. So it gets 1 blank for that. Over here, we have our M values for this column are -1, 0, 1, and then it repeats. So these are the 3 blanks for here and for here. Yes? Okay. Do you know the M numbers on your quantum numbers periodic table? Let's go back up to here. So these M values here, that tells you how many blanks you're going to get for each block. So when you're in the S block, you only have one option. You get one blank for your orbital diagrams. So titanium was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Is it 2 or 3 for titanium?
Take 8 and 10, it's a lot of fun.
I believe it's 3, right?
Well, I think it's 2. I think titanium's right here. Yes?
Oh.
Yeah?
Yeah.
Okay.
Yeah, you're right.
All right. So each one, for each thing here, however many M options I have for that section is how many blanks I'm going to get. So if I'm in an S orbital, it's going to get 1 blank. If I'm in a P orbital, it's going to get 3 blanks. That corresponds to these 3 orbitals. The bunk beds. You had 3 bunk beds in the pink room, right? That's what these are. So this is bunk bed 1, 2, and 3. And then you doubled up those bunk beds. So this is in the same orbital as this. It's the same orbital. It's the same space. Except you're getting 2 electrons in there instead of just 1. And then D's have 5 bunk beds in their room. Even though titanium only uses 2 bunk beds, the bottom bunks. Okay. Yes, no, maybe, maybe not. All right, so I think that was the... All right, so I'm giving you these electron configurations. They want to know what element it is. What trick do we use to figure out what element this is? Yeah.
Add up all the exponents.
Yep, you can add up all the exponents. Otherwise, if you can find this location on your periodic table, so 3D5, that's the other way you can do it. So 3D, if I'm in the D block, it's period -1, right? So 3D is going to be somewhere in here. Yes? And then I can just go over 5. 1, 2, 3, 4, 5. So it's manganese. That's the other way you can do it. This is 4s1. So what is it, 4s1? If I'm in the S block, am I in the period that I'm told that I'm in? Yes. So 4s1, 4s1 is potassium. And then this one is 4f1. So F is here. 4f, which row am I in?
6.
6. So I'm somewhere in here. And it was 4f 1, so it must be this guy. So if you pop over to your periodic table, that's LA. 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 I'm from LA. All right, there you go. Time for your homework. If you're not getting it, come and talk to me. We can share some more. And we talked about it in terms of chutes and ladders. Do you remember me talking about that? Okay, so today I am going to give you your ladders. I'm not going to give you any chutes. I'm going to give you ladders, which will make this a lot faster to do for these electron configurations. Okay, So for example, lead, if you were to write out lead's electron configuration, you would have to write all of that out. That gets stupid long, right? So what you do with these is you, on your periodic table, so I'm just going to run back up to a periodic table here. I'm going to find what I'm trying to do. So here's lead. That's the one that we're trying to do right now. Good? Everybody see that? You are going to back up. You can't go forward. You got to back up numerically until you hit the previous noble gas. So everybody knows that these are noble gases, right? We've talked about noble gases several times. So we're going to back up numerically. So 82, 81, 80, 71. What's after or before 71? Where's that at?
56.
Nope, not 56. I got to go to 70 next.
Oh, so 70. CD.
Down here. This is number 70.
Oh, no, that's 48. That's
Okay.
70.
Then I get to 57, 56, 55. What comes before 55? 54. We're at a noble gas. Yep.
So you have to go backwards?
You have to go backwards. Yep.
Okay.
Okay. You're going backwards to the previous noble gas. And what you will do then, you will put that noble gas in square brackets. And you will start your electron configuration from there. So, xenon, this is where I'm starting then. So what is my N value for these two? 6. What block am I in? How many electrons do I need to get to lead? I need both of them. Where do I go after 56? What comes after 56? This is kindergarten. Come on.
57.
57. Thank you. So I'm jumping down here to 57. Okay. What is my N value for this section?
N value.
N. What is my N value here?
4.
N equals what? N equals period
Period -2.
minus 2. So I am in period 6. 6 minus 2 is 4. What block am I in? F. And how many electrons do I need? I need all of these. How many are there? 14. After 70 comes chutes and ladders. After 70 is 71. There you go. Okay. So I'm going to go up to 71 now. What is my N value for this section? 5, because it's period minus 1. What is my block? D. And how many do I need? I need all 10 of them to get to here, yes? Okay, what comes after 80? 81. So I need these two here. What is my N value? 6. What block am I in? And how many electrons do I need to get to lead? 2. So that is your ladder in chutes and ladders. Okay? You took a ladder from hydrogen all the way to xenon. So that's your ladder. So you jump from 1 all the way up to 54. Still a lot faster than writing all of this out, yes? So essentially what you're doing is you're taking all of this stuff right here and replacing it with XE. And then you start from that point. Make sense? So your noble gases are like your ladders in chutes and ladders. All right, good. All right, talked about noble gases, talked about how to write lead here. If you are at a noble gas, you have to go back to the previous noble gas. Okay? So if they are asking you for the electron configuration of xenon, you cannot do this and be correct. You have to go back to krypton. Okay? And then start from there. So this would be 5s2, 4d10, 5p6. So that would be the electron configuration for krypton.
Can I write
Or
this down?
xenon, I mean. Huh?
Can I write this down?
There was just a discussion on the AP Chem teacher site about this very question, and everybody on there agreed that that's how you have to write it. You cannot do this if you're trying to do xenons one.
Is there like a reason?
I don't know. I have to go back to the thread and see if there was a reason. I can't get Facebook on this computer, so for some ridiculous reason that I still don't understand. So because I'm the only AP Chem teacher here, I don't have other people to like bounce ideas off of and stuff. So Facebook is really nice because you can go out there and find people that have, that understand the stuff and are doing lessons. And I get a bunch of ideas from people out there. Here's one on Lewis dot diagrams, which is what I'm getting ready to talk to you guys about here in just a second. Gas configuration. Let me see if it'll come up real fast here, Merritt. I'm gonna have to look. All right. One thing though that I just saw in there, it's a good reminder to you guys. If they ask for an electron configuration, you can always give them the noble gas configuration unless they say complete. If they say that they want the complete or unabbreviated form, then you have to give them this guy right here. Okay. So if they ask for the complete or unabbreviated form, this is the type that you would give them. Okay. So this guy. If they don't ask for it, then you can always give them the abbreviated form. Okay. So you'll have different times where that comes up. All right. So we're also going to talk about something called valence electrons. Okay. So valence electrons are your electrons in the outer shell. Okay. So when you are looking here at this, you can find the highest N values. So for this guy, these would be the highest N values. Those are going to be your valence electrons. So electrons in the outer energy levels. Okay. The easiest way to do this, And now I want you to switch slides. There we go. The easiest way to do this is to count columns. Okay. So if you want to know how many valence electrons, we're not going to include the D or F blocks. Okay. You're never going to have those this year in here. If you do get a D or an F, it just comes back to 2. It would come back to this guy because that's all you would have at that point. Okay. So the easiest way to do this is to count columns. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. That's as hard as it is. Okay. So simple counting up to 8. You don't even have to get to 10. So skip these. If they ask you these, what do you put down? 2. Okay. Because it would come back to your S here. So if I were to do the electron configuration for scandium, okay, I would go argon 4s2 3d1. Okay, highest N value is here. Right? Does that make sense? Because this 4th level is outside the 3rd level. It fills these electrons first, but this is outside of this. I know. You have to accept things. Sometimes you just have to accept them.
So these are, so 4s2, those are the valence electrons.
Those are the valence electrons.
Got it.
So S block. Yeah. And then you're just gonna go.
So look for the highest N value.
Okay, and that would.
That's your valence.
Okay.
So if we look at this lead again, even though these got filled in first, okay, these are still going to be your valence ones. So see, I have 2 6s there. Those are the highest N values. Those are my valence electrons.
Oh.
So lead is going to have 4 valence electrons.
Okay. Yeah.
If you go back to my 1, 2, skip a few technique, lead is right here. 1, 2, skip a few, 3, 4.
Wait, highest N value.
Yep.
Wait, what?
N.
Oh,
Remember
N
your quantum numbers. You had the N value,
Got it,
right?
got it.
Okay.
That's
So
why
your
we-
N value here, 6, is the highest N value that you have.
Got it.
And that's why it would never be the like the D block or the F block because they have subtractions in their periods. Okay.
Good. You got it worked out now? Good. Okay. All right. So the last thing we're going to talk about is the idea of these valence electrons and how we're going to draw these. And these Lewis dot diagrams are going to come back to you. Okay. They're going to come back when we are doing bonding in chapter 7 and 8. Right. So how do these things come together to form compounds is what 7 and 8 are about. Okay. So, when we do these, and I think I'm going to change this up. I think I'm going to change this up a little bit. We're going to go, I don't want 2 there. I want 1, 2, 3, 4. And this will be 5, 6, 7, 8. There we go. So change that. And I'm not that picky on this. I just want 1 around each side before we double up. Okay. So 1 around each side before we double up. That's what we're going for. I had thought about this and I went with this. And now there's been a bunch of debate on the AP Chem teacher site. And so now they got me thinking the other way. Honest to God, I don't think it's really that important. And that's kind of what they're coming down with. They're like, it's not that big a deal. Okay. I can see the rationale for this, but I think it's going to be a mess when we try to get into bonding if we do this. So, all right. So noble gas configuration for M or NB. And then which noble gas? Which noble gas? Oh, which noble gas? Okay, I see what they're asking. And then they want the Lewis dot diagram. So, all right, so let's find NB here. We said it is number 41 right here. Okay, so the previous noble gas they asked about would be krypton. So then I'm going to go krypton, Kr. Krypton's number is, can't read it on here. It's krypton's number. Can't read it.
I think we just added the noble gas, right? So
36.
KR and then we're done with it.
No.
No?
Oh, well, for the first one, yeah. And then the second part of that question asked for the noble gas configuration.
Yeah, I see.
So I'm keeping going here because I want to do part 2 now.
All right.
All right. So after 36 is Chutes and Ladders. After 36 is 100 Days of Kindergarten. Come on. After 36 is 37. There you go. So 37, this is 38, this is 39, this is 40. Okay, and this would be 41. So 37, what is my N value for these two?
5.
5. What block am I in?
S.
And I need both of them. Then after 38 comes 39. What is my N value for 39, 40, and 41?
D.
That's the D block, but what is my N value? 4. D. And I need how many electrons? 3. So that is much, much faster than the previous one. Now, they asked for the Lewis dot structure for this. It would just be 2 dots. I don't really like that one because I'm not going to really ask you like on a test or anything for any of those that are in those transition states. And I'm not going to be asking you really for them when we're doing bonding and stuff. So let's just do the Lewis dot structure for SB. Okay, we're going to count 1, 2, skip a few, 3, 4, 5. 1, 2, 3, 4, and I don't care where the 5th one goes. I'm going to put it up top. So there's SB. Easy enough. North, south, east, west, and then pick a point.
I'm confused on how you did that.
What? How I got the 5 or?
No, the Lewis dot diagram.
Okay, so here's my element.
Hey, we're doing SB.
I'm doing this one now. Yeah, I already did this one.
Okay.
I did 2 dots. 1, 2. And now I'm just throwing an extra one out there. So SB has 5. You understand 5? Where I got the 5 from? So I'm counting columns. 1, 2, 3, 4, 5.
So N value.
No, not my N value. I'm just counting columns. 1, 2, 3, 4, 5. Anything in this column here is going to have 5 valence electrons. So any of these, I could switch out SB and I could write nitrogen. I could write
Oh, so it's just big.
AS. Yep, it's just valence electrons.
Okay.
That's all you're looking for. And anything in this column is going to have 5.
Oh my goodness.
Yeah. Then why'd you put an extra one on niobium?
I just put 2 on there. 1, 2.
Oh.
It's right here, so it would have these 2.
Oh, I thought you put a third. I saw a third. My bad.
Wait, then how did you? I still don't understand.
It's just a way of putting valence electrons. You just put dots around it.
So, you know how your electron configuration for these? You know the electron configuration, right? Yeah.
So if there were one in like the D block, what would that be? Would it just be 2 then?
Yep.
Or-
Yep, that's what NB is in the D block. So it just has 2. Anything in the D block or F block is going to have 2. Because it's that S orbital is all you got. That's your highest N value. So if we were to, let's just look at the electron configuration for this period 2 elements. Okay, I'm going to do the electron configuration for those. Can I put up? Trying to figure out here. Hold on. Let me just find a blank slide here. Okay. So lithium, right? Lithium is 1s2, 2s1. So what's its highest N value?
3.
There's not a 3 up here. So what is its N value?
Sorry, I'm counting electrons. So
2.
2.
2. So this is its highest N value. How many electrons are there?
On
Just
that
one. So lithium would have 1 dot for its Lewis dot. Beryllium is 1s2, 2s2. What is its highest N value?
2.
2. It's going to have 2 dots. 1, 2. Then we move over to boron. Boron is 1s2, 2s2, 2p6. No, 2p1, I'm sorry. 2p1. So its highest N value is 2. I have 3 electrons now. So I have 2 here and 1 here. That's a total of 3. So it's going to be boron 1, 2, 3. Move to carbon. 1s2, 2s2, 2p2. N value, I'm looking here. Carbon will be 1, 2, 3, 4. Good. Nitrogen. 1s2, 2s2, 2p3. It's going to have 5 valence electrons. There's my 5. Oxygen. Oxygen's going to have 6 electrons then. Does that make sense? Where I'm getting this from? 1, 2, 3, 4, 5, 6. Fluorine will have 7, and neon will have 8. So like I said, if you just count the columns that they're in, this is 1. Anything in here is going to have 1 valence electron. Anything here will have 2 valence electrons. Anything here will have 3, 4, 5, 6, 7, 8, except for helium. Helium only has 2. Because remember, helium, when we're doing these electron configurations, is over here.
So about how you arrange the dots.
I don't care. Just don't double up until you have 5. So if you have nitrogen, for example, 1, 2, 3, 4, and then double up. And I don't care if you double up on the north, the south, the east, or the west. It doesn't matter.
So I could go nitrogen, electron here, electron here, electron here, electron here, then electron.
Yep. You can go clockwise, you can go counterclockwise, whatever you want to do.
Like you said, it doesn't really matter.
Doesn't matter. No. When you get to college, they may have some special way of doing it, but most people don't care. Sometimes you run into these professors that are holier than thou, and then they care because they want to show off how smart they are. But it really is not a big deal, especially at this level. It's fine. All right. Good? Making sense? Making more sense now? Okay. All right. So you got a little bit of time. We get out of here today at 33. So you got about 10 minutes. You can probably knock out your homework in 10 minutes. So.